Saxon Advanced Mathematics, lesson 94. This is a lesson that I've been waiting to share with you for a long time. I think it was like lesson 43 when we first learned about sinusoids. We learned that sine and cosine can be graphed, and they make these cool up and down waves, right? And I told you that someday I would explain to you tangent. Today is that day. Before we do tangent, though, we're going to talk about secant and cosecant. We'll get to tangent. He's a bit of a problem child, so we're going to save him till the very end. But cosecant and secant are kind of fun. Before we start, I want to remind you that secant is the reciprocal function of cosine, and cosecant is the reciprocal function of sine. That's going to be important information in just a few minutes. So what we're going to do, for example, 94.1 is write the name of the graph. So what I'm going to do is I'm going to copy it into, there are two of them actually, so I'm going to do them separately. The first one looks like this, and they're weird little thingies. There's a center line, and this is divided into 3 bits, well, 2 really. And then we have numbers and then we have a y-axis. But look at what's happening. The actual curve looks like this. And like this. Notice these shapes. They fit within what looks like half a period, right? If the full period is 360, each one of these curves fits within 180 degrees, right? This is the first 180, that's the second 180. They start at what's usually the edge of the sinusoid, and they go out. They're not very neat. They're going infinitely along within this space. They're never going to touch this dotted line, okay? But they fill it infinitely. How do we write the equation of that? Well, here comes the fun news. What we do is we write the ghost function. Ooh. The ghost function fills in everywhere that this weird thing we're doing isn't. So, okay, so what I didn't think about anything mathematical. I just saw, okay, it's going to curve down and it's going to curve up, and I just kind of filled in the way a normal sinusoid curve would look. This green thing, that's not a sinusoid, is it? But I could draw a sinusoid kind of within it. That's called the ghost function. Now what I'm going to do is I'm going to write the equation of that ghost function. What? How am I going to do that? Well, I'm going to recognize that the ghost function is actually an old friend of ours, isn't it? It rises out of 0, it peaks at 90 degrees at 1, it comes back down and then bottoms out at -1 and then comes back up. That's a sine function, is all that is. That's a very basic sine function. So I can write that that is y equals the sine of theta, right? There's no adjustments to this at all. There's no phase angle, there's no period, skinny or fat. The center line, all of this is just very straightforward. Once I identify the ghost function, it's very easy for me to go back in and go, okay, sine is related to cosecant. So these green lines are actually the cosecant function. That is the name of those green graphs. It's not a sinusoid because it's not this smooth continuous thing. The ghost function is a sinusoid, but the graph of cosecant is just that. It's a graph, it's not a sinusoid. But that's cool, isn't it? That the way you identify it is by drawing in the ghost function. Let's try another one. And now you can spoil it for yourself. Oh, I'm sorry, it's not, it's part B, if you will. This is A. All right, I'm gonna do the same thing. I'm gonna draw a graph. It looks like this. This time my dotted lines are a little different. Look at how my numbers fall. This time the dotted lines that were at 180 and 360 are now at 90 and 270. That's a little different. And look at how this graph looks. Instead of being two U-shapes, one up, one down, this is one down, but it's kind of like a broken U-shape, isn't it? Half of it is here, and half of it is there. That's kind of weird, isn't it? All right, we're gonna do the very same thing. We're going to graph the ghost function. Is that John's word, or did I make that up? I made that up. All right. So again, what we do, I'm not thinking about this in any great detail. I'm just saying, okay, I want my curve to bottom out here, and I want it to come down from here. So let's just make it go through the quadrants. Right? I make sure that it hits here at 90 and here at 270, but I'm just filling in where it isn't. And I see I've drawn a cosine function. My ghost function is cosine. It starts high, it goes down low, it completes its cycle in 360. There's no weird center line or amplitude issues. There's no phase shifts. It's just a cute little cosine curve. Cosine is related to secant, and so that I know that this broken U thing, this is a secant graph. All right? You can recalculate that anytime you want, but here's a little trick. Cosecant has a repeat of 2 C's in it. That reminds me that there are 2 whole U's in a cosecant graph. Secant only has 1 C, and that reminds me that there's only 1 U that is unbroken, and then the other 2 are weirdos, right? So this has 1 U, this has 2 U's. That's a quickie way to remind yourself, but drawing in the ghost functions will work every single time. Okay, now that we've seen the basics of cosecant and secant, let's look at some problems that are slightly, and I do mean slightly more complicated, and see what we can do with those. Again, there are 2 of them, so this is example 94. I'm gonna call it A, John doesn't, and I'm gonna draw it for you. Okay, we can see that this is going to be probably, based on where these dividing lines are, we think this is going to be 2 full U's, which would be cosecant. Let's test our theory in just a second. But I see something else is happening here. It's not quite as even and simple as it was last time. Okay, so there's my curve. Like I said, I'm suspecting cosecant, but what about this? How do we deal with that? Okay, just like before, we draw in our ghost functions. And I know I'm going to want to go down and up. So it's going to be like this. Now, I can see that's a sine function because it comes up out of 0. But I can see that my center line is 0, but my amplitude is off by a bit, right? So I would write this. If I was writing the sine curve, I would write it as, let's see, y equals a plus b times sine or cosine, whichever you've got. Is like that, right? That's the whole big thing. This is where we write a change in the amplitude. This is the center line. And this is the period coefficient, right? We have to calculate that. Oops. And D is the phase angle. And I'm not going to get into all of the nuances of those because right now we're just trying to remember which letter is which thing. The amplitude goes here, so I will write 0.5, and this is a sine curve, like we said. There's the equation of the sine curve. And the good news is we did identify this as cosecant. We know that because cosecant is the reciprocal of sine. We also know the U's, blah, blah, blah. But we write the equation in the exact same format. So we don't have to rethink any of this A, B, C, D stuff. Literally just write the ghost function as you already know how to do, and then just change the name to cosecant. All right, and then the last one is 94b. And this picture looks like this. $90, $180, $270, $360. So we can just tell by these dotted lines, this is the broken U, so that means it must be secant. But check this out. Okay, let me draw in. Again, the graphs of cosecant and secant are not sinusoids because a sinusoid has to be that smooth rippling thing. They're graphs, but they're not sinusoids. These U's fit perfectly between the dotted lines. The dotted lines mean they can never touch here because in this case, it's going to be secant. We know that, spoilers. Secant is undefined at 90 degrees and it's undefined at 270 degrees. So that line can never touch exactly where the dotties are. Comes right up close next to it, but it can never touch there. That's why these dotted lines are here. In the second part of this lesson, we're also going to have dotted lines. Okay, so let's write our ghost function in. Again, I know it's going to go up where the green one goes down, and it's going to go down where the green one goes up. And I say, look, it's a cosine function. But I can see there's some changes here. My center line is 10. So I'm going to put that right there. Plus, then my amplitude is 0.5. And this is cosine. I don't have any other adjustments to make. So this is, oh, I should put theta. I haven't been doing that on any of these, have I? All of these should have thetas on them. My bad. Let me go back and fix the other ones too. Oh, I did those right. But you know what I forgot to do here? Dun da da da. Problems are not over till I'm smiling. Okay. So I forgot it just here. And now, again, once I've written the sinusoid, I copy the exact equation and just sub out the reciprocal. Cosine goes with secant. So our theory holds that the C's in the letters will help us identify which one is which, but we don't need to rely on that little parlor trick. We draw in the ghost function and we'll always get it right. And then again, like I said, if there are complications, and honestly, we're not getting into complications with these two. We'll just get into complications with A and B. But you just write the ghost function exactly the way it should be and then switch out the name of the function. And this is the right one. Okay. All right, we've put it off as long as we can. It's time now to talk about tangent. Now, tangent is a problem child. The reason that tangent and cotangent are problem child, let's just talk about tangent for now, is because at some values, tangent is undefined. And I'm getting out my unit circle so we can talk about that. Here's the thing about tangent. We can calculate it from our unit circle by putting sine over cosine. So let's just make a little list here. Tangent at 0 degrees equals, it's always sine over cosine, right? 0 over 1. That's okay, that's 0. We're fine with that. Tangent at 90 degrees. At 90 degrees, sine over cosine is 1 over 0. Uh-oh. That's undefined. We just blew up the kingdom. It's a problem. All right, let's carry on. Tangent of 180 degrees. Unit circle, I'm spinning it so it's right side up for you. At 180, sine over cosine is 0 over minus 1. Which is fine, that's just 0. And then tangent of 270 degrees equals, so here we are, 270. Sine over cosine is minus 1 over 0. Kingdom just blew up again, right? So that's undefined. This is what causes us such a problem with graphing tangent, is we have these undefined values. Now, let's squeeze in a couple more values for tangent because we have the extremes. We have kind of extremes here, don't we? So what happens No, I don't need to do that. Let's just go backwards. Tangent of minus 90 degrees will also be undefined, right? And tangent of minus 180 will be 0. So let's put this together onto a chart and see what it looks like. I'm going to keep this page handy. I'm going to rip it out and keep it handy so that we can graph and refer to it. I'm going to move my Y. No, I'll leave it here. Okay, the first thing we want to do, here, let me put in my degrees. And I'm going to have it repeat. Oh, I'm sorry. This is 450. And 540. And 630, and then the last one will be 720. Okay, so we'll do 2 full cycles. Now, I know that at 90 degrees and 270 degrees, it's undefined. So what I can do is at these angles, I'm going to put in this dotted line, which means undefined, which means we can never let tangent touch this line. The graph can never touch this line because these all mean there's trouble at that angle marker. And we can see it's every 80 degrees, so I can fill these in as well. Or 180 degrees, not 80. Okay, so at all of these points, tangent is undefined, so we cannot fill it in. I got this from this. I got this, we've taken care of, we've graphed this, and we've graphed this. I guess I'll go back and do this. At 90, at minus 90, it's also undefined. In a minute, you'll see why I'm hemming and hawing about these negative numbers. Okay? So just like with secant and cosecant, we can't let our picture, our graph of tangent, touch at any of those points. Now, we can let it hit 0. At 0 degrees, it can be 0. Well, it has to be, right? At 180 degrees, it's 0. At minus 180, it's 0. Well, that's way off this way. But we can see the other pattern is those numbers. Okay, so what's it doing in between? Well, we can spend a lot of time graphing, which I don't want to do. But what we will see is that if you remember that tangent equals sine over cosine, we can use this to calculate values at any of these other points along the way that we want. So let's take, for example, let's take at 45 degrees. The tangent of 45 degrees will be, here we are, tangent of 45 degrees is square root of 2 over square root of 2, sine over cosine. That is 1. Okay, and then we can look at this quickly and see, oh, well, at 225, it would also be positive 1, right? So let's put that in. At 225 degrees, which is halfway in between these two, it's going to be at 1. So let's graph a 1 in here. At 180, it's 1. No, I'm sorry. It was at 45 degrees. 45 degrees, and at 225 degrees, which is here. There. What about the other two? What if we take the tangent of 135, right? I'm picking this red angle because I know that sine is equal to cosine, so it'll give me really easy numbers. At 135, it's minus square root of 2 over 2 over, right? So this equals negative 1. And this will be the same as the tangent at the opposite angle. Here's 135. So over here at 315, I'll also get a negative 1, won't I? The negative's on the other side, but same difference. So 315, these two, let me draw a line to separate. These two angles both have a tangent of 1. These two angles both have a tangent of negative 1. So let's graph those in. 135 is halfway between these two. And 315 is halfway between these two. Now, we could keep going. We could pick more angles. We could run the calculations off of our unit circle, and we could block them up, but I want to show you what's happening here. We can also, every 180, we know this is going to be the same. So I know there's going to be one here, and I know there's going to be, right? I'm just repeating the pattern in all of these. There's one there, and there's one there. Now we've got enough to draw the pattern. Look what it does. Tangent makes this swoopy shape. See how I'm connecting the dots in each section? I could graph in a lot more to prove my case, but I don't want you to get lost in the little calculations. I just want you to see that by using our unit circle, we can calculate some values for tangent, and it shows us that tangent makes this, it's like a cubic function kind of, isn't it? It makes this swooping shape that repeats itself. This is why the graph for tangent is so unsatisfying, is because it doesn't make a sinusoid. It just makes this graph with these undefined sections similar to secant and cosecant. All right, so this equals y equals the tangent of theta. And then again, we could do this calculation using the unit circle. We could spend a lot of time sorting it out, but I'm just going to show you. This is how then cotangent works. Oh no, it does go down. As the reciprocal function, it's just the reverse. And this is y equals the cotangent of theta, okay? Again, we can use reciprocal functions pair really nicely in these graphs. We can use one to draw the other. Okay, so what we did to graph tangent is we used values off our unit circle. First, I graphed the quadrants, and I figured out that, oh, here's this page. First, we did the quadrantal angles, positive and negative. Then we got those in. We used those to draw our undefined lines and then to draw the center of each of the curves. And then we used other values, and I calculated them here. Again, remembering that Tangent always equals sine over cosine. We can use our unit circle. I used the 45-degree related angles, but you can use any of them and get more different values. But we were able to use sine over cosine to create values for tangent. And then by graphing enough of them, we were able to draw the picture. Now that you've seen it, you'll never forget it. Tangent also has undefined spaces, but instead of making the U shapes, like cosecant and secant, this makes, I don't know, what do you even call those, S shapes? It's a very distinctive, oops. My dog just filled with my foam cords. She's getting restless for a walk, so she's starting, come here. She's playing around by the cords. All right, that's all I have to say. We are not gonna go very far with these functions that we learned today, secant, cosecant, tangent, and cotangent, because they're not sinusoids. They're just graphs, and they do not have the same mathematical value as our good old friends sine and cosine. So, but, you know, question answered, because you've been wondering. I know, you've been up late nights all this time wondering, when are we ever gonna get to tangent in the sinusoid work? Today's the day. Thank you, goodbye.